Okay, kids, we're going to start chapter 11 now. And what I decided to do is to combine sections 11.1 and 11.2. And so we're going to begin with section 11.1, which is understanding the concept of area. Going to give you a minute or two to hit the pause button on the recording and go ahead and copy this down and copy down the drawing for number 1. So go ahead and take a couple of seconds and do that, and then when you hit start again, we'll continue with the lesson. In chapter 11, the first thing we talk about is the concept of area. And I really like this definition. It says that the area of any shape that we're going to entail in chapter 11 is the number of square units that's covered by a bounded region. And of course, in chapter 11, we're going to get into everything, but we start off with rectangles and squares. The area of a rectangle is equal to the base times the height. Some books will use length times width, and that's fine. I have no problem with that. We use base times height in our textbook, and so I'm going to use base times height. And then, of course, the area of a square, because all sides are congruent, would just be able to take one side and square it, which is the same thing as taking the base times the height. And so the key things I want to stress in the chapter 11 to start off is the units that we use for area are always square units. In chapter 10, we dealt with circumference and perimeter, and those units were single units. The units here are square units, and so the answers to all of the problems in chapter 11 are going to involve square inches, square centimeters, square yards, and so on. Tomorrow in class, we'll put up some different shapes on the board for you, show you what a square yard looks like, and so on. This is problem number 1 from the section, and I'm going to fill this in for you. There's several ways to do this problem. The one way they do it is called a divide and conquer method. And what they do with divide and conquer is they take the shape and they form several triangles, rectangles, whatever they're trying to do here. I just formed 3 rectangles. I'm going to call this rectangle number 1, rectangle number 2, and rectangle number 3. And when we put in the values that were given, I'm going to put those in. 5 units, 4 units, 5 units, 2 units, 3 units, 6 units, and 3 units here. If we look at we want to calculate the total area. The total area for this particular shape is going to equal the area of all 3 rectangles. So if we look at number 1, we have a base of 3 times a height of 6. And if you look at the second shape, we have a base of 5. Now the height of the second shape goes from this position to this position. And so what you have to do is you have to add the 2 vertical lengths here. We have 5 here. We have 3 here. 5 plus 3 is 8, so that's a 5 by 8 rectangle. And then the third rectangle is a base of 4 and a height of 5. And when you multiply these together, you get 18 plus 40 plus 20, 78 square units. Not sure what happened there. We'll fix that for you. 78 square units, and that's the area for that shape. Now there's another way to do this problem. If you need to pause that and copy it down, that's fine. There is another way to do that problem. I'm going to go over that tomorrow with you in class, and that technique would involve making the entire shape one big rectangle by extending the sides. And now what I would do is I would take this entire base times this entire height and then subtract these areas in here from it. And we'll work on that tomorrow. So there's two ways to do this type of problem. I sort of like the divide and conquer technique the best. And those are some of the problems we'll be doing in 11.1. Now when you get to 11.2, you get into areas of specific shapes, and we start with parallelograms. The area of a parallelogram is the base times the height. It doesn't really matter if the parallelogram is a rhombus, or if it's a rectangle, or if it's a square, or if it's just a plain old parallelogram. It's base times height. Here's the difference between this and what we just did. The base can be either one of these lengths, the one on top or the one on bottom that's parallel. The height, however, is not one of the sides of the parallelogram. It's this length here. This is the, man, what's going on here? If I go too fast, it loses it. There. The height is that length. It's the length of the altitude. Now the proof of this is very simple, and we're going to prove this actually on a hands-on activity tomorrow. But basically what you would do is you're going to cut. We're going to have you draw a parallelogram in class tomorrow, and then you're going to cut right along this broken edge here. You're going to cut this off. And you're going to take this triangle and you're going to move it, and you're going to find that it's going to fit perfectly right in here. That triangle is going to fit perfectly because these two sides are congruent because it's a parallelogram. This is a right triangle, so that makes this a right angle. And this length is the same length as this length. And so because of HL, you're going to be able to put that triangle, when you cut it out, over on the side here, and now look what you've formed. You formed a rectangle, just pretending that this is no longer here, and look at the dimensions of the rectangle. The base is B, and the height is the altitude inside the parallelogram. So we've proven the area of a parallelogram is the same as the area of a rectangle. It's base times height. Now let's look at the area of a triangle. Well, a triangle can be formed from a rectangle. If we take this rectangle right here and we form a diagonal inside this rectangle, if the entire rectangle is base times height, the diagonal forms two congruent triangles, and so each one of these would be half of the base times the height. And so when you're trying to calculate the area of a triangle, you can take the base of the triangle times the height of the triangle, and then divide the answer by 2 or take half of it. Now I know there's people out there that are looking at this and they're saying, well, wait a minute, what happens when it's not a right triangle? What happens if our triangle is shaped like this? Maybe it's an obtuse triangle. Do we still use 1/2 base times height? We'll save that answer for you tomorrow. So again, if you need to go back, start at the beginning. Make sure you have all the notes. We're doing 2 lessons tomorrow. Plenty of time for examples. Going to get most of it done in class. Not too much homework to look forward to. Have a nice evening, kids.